Let's take a look at cryptography. It seems like a mysterious process to so many people, but really what's going on is we are concealing, we're hiding something that was out in the open before. And cryptography really has three parts to it. It has what we call plain text or clear text. Now, that doesn't mean it's text. It means that it is an unencrypted something, file, folder, network packet, something that was not encrypted. We then run that thing through a mathematical formula called an algorithm. An algorithm does something to it. So the algorithm could be as simple as shift it X number of characters to the left. That would be like a super simple algorithm. But what is X? That's the missing part. That's something called the key. The key is anything that can be converted to a set of numbers. It could be a word, a phrase, an image. If we can convert it to numbers, that's the key. And you take that clear text, that unencrypted thing, you run it through an algorithm, and the key tells it how much to do something. So like if the algorithm is shift the letters over X number of letters, and the algorithm, or the key rather, is 1, then we would shift all the letters over 1. So A would become B, and B would become C, and C would become D. That's a really simple example of cryptography. So we're going to start with unprotected data, as we can see in the diagram. We will run it through encryption, and now it's protected. This is the most assured way of protecting confidentiality of data, is to actually encrypt it. So even if people get past the operating system, even if they log on to somebody, they hack past the operating system, even if they get past the application, the data itself is encrypted. And that's the whole concept behind BitLocker when you're encrypting whole drives or sending things that have been encrypted in email. So we have the protected data. If we ever need to get to the data, we need to decrypt. So we might encrypt a transmission. It's encrypted here, it travels encrypted, and at the very end it becomes decrypted so they can access the transmission and the data in a decrypted format. And when we decrypt it, it becomes unprotected. You can see the potential here as an auditor. Are we encrypting, but is there anywhere from here to here that the encryption process is not working? Like, is it encrypted here, but then is it sent in clear text? Or is it transmitted in encrypted format, but is it stored in clear text? So we have to look at, is it ever decrypted at any point? So we start out with encryption on our desktop here, and we've got this clear text file or document. We run it through an algorithm, a mathematical formula. We apply a key, which is basically a number that tells the algorithm how much to shift something, and we end up with ciphertext. I'd like to actually demo this. If you've never actually seen the before and after encryption, it's actually quite fun. I'm going to use a well-known little tool so you can actually see the encryption process. This is a little tool that is used in the security community. It's free, and it has some well-known hashing or encryption algorithms. It has Rindall, which is now the basis for the Advanced Encrypting Standard, AES. It has Blowfish, it has IDEA, Twofish. And we're just going to encrypt something. I'm just going to create a simple text file right here on the desktop. And I'm just going to put in a very simple sort of sentence in it. I'm just going to call this before. And I'm going to open it up. And this is clear text, period. So this is my unencrypted clear text file. I'm going to save it. And I'm going to run this thing through an encrypting algorithm. And I'll pick Rindall, which is the basically what was chosen for the Advanced Encrypting Standard, AES, which is the successor to DES. And so let's browse for the before file. Now this tool creates encrypted copies, so let's browse for it on the desktop. Let's go down and find it. There's before. Okay, now I've got this loaded, and it's going to create an encrypted copy. This particular tool does not encrypt the original. So we're going to call this thing after. And we're going to put in a passphrase here, which will be turned into a number. secret, S-E-C-R-E-T. And that is actually with an uppercase S. And let's encrypt the file. Let me click Encrypt File down here. Click it, File Encrypted, okay. And I can see over here that here is the encrypted copy. Let me bring it over so we can take a look at it. Here it is here. I'm going to open it up with a text editor. So let's open it up with Notepad, which is what we originally created it. And now you can see the encrypted version. I'd like to point something out about ciphertext. Look closely. You'll see that all these characters, you really don't see any of them being repeated. One of the things about cryptography, a good encryption algorithm tries to take something that is unencrypted and turn it into something with no repeat patterns, which is basically why encrypted files and compression don't work too well together. Compression looks for repeat patterns so that it can just have a shortcut to represent a whole bunch of repeat patterns. In encryption, you try to have no repeat patterns. Have you ever played those word puzzle games where you're looking for repeat patterns and you kind of figure out what the letters are? So you look for like the most common one, like the letter E or the letter A, or you look for like single words, just one, it's got to be A or I. Well, that's kind of one way we would approach trying to break ciphertext, by looking for repeat patterns. Notice there are no repeat patterns here. If we compare this ciphertext to the original, let's compare the two together here. Do you notice something else? Do you notice that the original is only this long? And yet the ciphertext, the encrypted version, is this long. You see that? One thing you need to be aware of is that when you encrypt things, be they network packets or files or whatever, you almost always make them bigger. Just the very nature of trying to have no repeat patterns is going to make it bigger. From a system administrator perspective, that takes more disk space. From a network administrator perspective, that adds more traffic when you send encrypted packets across the network. As an IS auditor, we are interested in, are they applying encryption where it's important or where they need to or where they claim that they're doing it. And the next thing is, what algorithm are they using? In this case, we used Reindahl. And also, are they protecting the keys so nobody except authorized people know the actual keys? So we now know with encryption that you start with something in clear text or unencrypted, you run it through an algorithm, and you use a key, which could be anything that is ultimately reduced to a number. And out of that comes ciphertext. The next thing we're going to look at are three sort of approaches to encryption: symmetric, asymmetric, and hashing.